Okay, so hello everyone, welcome to my channel. So today we'll start a new chapter, which is differentiation. Okay, so today we are starting this differentiation. So like the previous topic which we covered, which was called integration, differentiation also has a lot of methods on how, or there are a lot of methods employed, okay, which, or methods which can be used to differentiate. They are plenty depending on the situation. Okay, so what is important is knowing all the methods, so that when you're given a situation, you can tell that, oh, this one I can easily employ, this one I can easily employ, this method is best, this method is best. Okay, so so the first part we'll cover is, differentiation by first principle. Okay, so first principle. So okay, I consider first principle to be one of the tedious things. It's very tedious. So if you're finding, let's just look at some nomenclature. Let's say you have y equal to x squared. Then you want to differentiate this. So we are differentiating y with respect to x. So it will be dy over dx. We are differentiating y with respect to x. So the nomenclature here is dy dx. So other books, this will just write as y prime. So y prime, it means dy dx, or f of x prime. So some books they'll say y, they write it y because y is a function of x. So this is the same as f of x is equals to x squared. Okay, so this is just a function. So this function, let me just write it better, not like this. You write it like this, f. So this function it has variable x and y, then you write equal to x squared. Okay, so all you know, if we say find, let me say for example I say find y prime, I'm just telling you to differentiate. Okay, and also say f of x prime, I'm telling you to differentiate. Or I say find dy dx, I'm telling you to what? Differentiate. Okay, so you need to be familiar with this. So I say y power dash, this is differentiation. Okay, f of x power dash, it means differentiation. Okay, so having said that, let's now focus on the main topic of our discussion, which is first principle. So how do we use first principle? So first principle uses a formula. So this formula says if you have a function and you want to differentiate that function, let's say you have a function y which equals to, let's say, s with a coefficient, and let's say b x, let's say this for example 2, this, or 3. Yeah, you can have a function, etc, etc. So if you want to find the derivative of this function, the derivative is same as the differentiate derivative. Okay, so this is just same it means if you differentiate this function, so if you differentiate this function, you're going to employ this formula y dash, which is the derivative of this function, is f of x plus h minus f of x divided by h. So this can also be written as, I've already shown you the nomenclature. So f of x power 1 or power dash equals to f of x plus h minus f of x over h. Okay, so how do you use this formula? So the formula, you need to know this formula. You need to know this formula, very, very important, because you can't solve by first principle. So if they specify to say use first principle, you have to use first principle. So this is the first principle formula. So if you're given a question, first of all, you need to write the formula for calculating. What is the formula? So the formula is f of x plus h minus f of x over h. So don't worry on how to say which one, how do I know which one is f, what is x plus h. Okay, so let's get our examples. So quickly paste the examples here. Okay, so here we need to first, so for example, let's pick a f of x is equals to negative 3x. So we already know this part, this one. We already know this part. This is the one, the question given. Okay, so now we need to find x plus h. So how do you get x plus h? So x plus h, what it means, x plus h, what it means is, in this equation where there is x, we are removing that part where there is x and substitute it with x plus h. So we write negative 3. So where there is x, we write x plus h. So I hope you guys are following. So we're just concerned on the part where there is x, the part which has contained x. The x, we are removing it and putting x plus h. Okay, so we can expand this if you want. So this will be negative 3 by x to be negative 3x minus negative 3 by positive h minus 3h. Okay, so now we have x plus h, fx plus h, we have f of x. We can employ the formula. So we say f of x dash is equals to, so first of all we write the formula x plus h minus f of x everything divided by h. Okay. Oh, I forgot one thing. Sorry. So this formula is written like this. Sorry. So it's the limit. You are taking the limit as h approaches 0, then fx plus h minus f of x. Okay, so sorry. Okay, so you are taking the limit. So what is the value of f of x as h approaches 0? So as h is heading to 0, what is the value of f of x? Okay, so sorry. So here you are supposed to write limit. Okay, so like that. Okay, so don't forget to write the limit. Okay, so don't be like me, you don't have to forget. Okay, so let me write it. Okay, fx plus h minus fx. So this is the formula for differentiating using first principle. So sorry. Okay, so let's continue now. So we write f of x power 1 equals to, so you write limit as h approaches 0. So you write now fx plus h. So what is f? x plus h is this one, negative 3x minus 3h. So we write negative 3x minus 3h. Okay, minus, what is f of x? F of x is what? Negative 3x. So, okay, so you write here negative 3x. So everything over h. Okay, so f x prime limit as h approaches 0. So this is negative 3x minus 3h. So negative to be positive, 3x over h. Okay. This will result into fx prime equal to, so we know this and this, they have alternating signs. 3x, we have plus 3x minus 3h over, so there is a limit here. Okay, limit as h approaches to 0 of h. Okay, so if you have negative 3 plus 3, the answer is 0 because they have two alternating signs. So if you have a number line, negative 1, negative 2, negative 3, so you go to negative 3 from here, 1, 2, 3. Then this side is telling you to go backwards 3 steps. This is positive, so we are changing direction, 1, 2, 3. So we'll be at 0. Okay, so alternating signs, if you're adding or subtracting, you know they have to give you at 0. Okay. Okay, so this will be f of x. So this and this will be 0. We'll have minus 3h over h. So h, oh, sorry, there is a limit here. How do I keep on forgetting to write the limit? Okay, as h approaches 0. So f of x equals to limit as h approaches to 0. So h and h will cancel. So we'll have negative 3 here. So limit as h approaches 0. So we don't have h here. You can see h as it approaches 0 here, it won't affect this number here. You've seen there is no h here. So meaning the limit as h approaches 0 is just negative 3. So is negative 3. So this is your answer. The derivative of that function is negative 3. So let's answer part B. Let's answer part B. So part B. So let's see. F of x is what for part B? So f of x is c. Then what do we do next? F x plus h. So where there is x, you put, what do you put where there is, x? You put x plus h. So do we have x here? No. Then what do we write if we don't have x? Meaning we have what? It will be just c, the constant, because we don't have x. We don't have x, so f of x, x plus h is also c, because we don't have x. If we had x, we could have said where there is x, everywhere where there is x, we put x plus h. But now we don't have. So in this question, x plus h is just c, a constant. So c can be any number. It can be 10, it can be 11, any number. So you write the formula now. F of x prime equal to Okay, so sorry about that. Okay. So we write the formula now. I don't know why this application keeps on. Okay. We need to find the data out. Okay. So okay, so we're here. So the formula is limit as h approaches 0 fx plus h minus fx over h. Okay, so let's put our values. Limit as h approaches 0, f of x is c, minus what is f of x is also c over h. Okay, so limit as h tends to 0, so c minus c, it will be 0 over h. So 0 divided by any number is 0. Hope you guys know that. So f(x) limit as h approaches 0. So this 0 divided by h is 0. Okay, so limit as h approaches 0. We don't have h here. So the answer is just 0. So 0. Okay, so hope you followed through. So let's go to C. So we come to C. Okay, so C, we have C. So we have C. We have f of x equal to 4 x squared minus 2x squared plus 4. Okay, so this one can be simplified. We know f of x, 4x minus 3x, they are both squared, so this would be 2x squared plus 4. Okay, so this is our f of x. Yeah, so you can just subtract here. This is, they both have squares, so 4 minus 4x squared minus 2x squared, this has 2x squared. Okay, so let's write now f x plus h. So in this equation f of x, where there is x, you substitute x plus h. So you say 2, where there is x, we write x plus h squared. Remember x here is squared, so you write x plus h squared plus 4. Okay, so let's expand this. So I like doing it old school. So you have x plus h, there are 2, so x plus h. So you're expanding this, you're multiplying x by everything here, h by everything inside. So you have x plus h, plus, there is plus here. Okay, so x plus h. Okay, so x by x, that's x squared, plus x plus h plus xh, plus h plus x multiplied by h, it will be h, xh. Okay, h by h, h squared. Okay, so x squared, if you add this will give you 2 because they both have coefficients 1. Okay, xh plus h. Okay, so this is what is here, so we'll substitute. So we'll say x plus h equals to 2, then x squared plus 2xh plus h squared minus, so we are, oh sorry, plus 4. Okay, so here plus 4. So we can expand this further by multiplying by 2 throughout. So this will be 2x squared plus 4xh plus 2h squared minus 4. Okay, so now we apply the formula we have. So we have our x plus h. So now we write the formula: prime equal to limit as h approaches to 0 f of x plus h minus f of x over h. Okay, so now we have f of x plus h. This is equals to limit as h approaches to 0. So you write now 2x squared plus 4xh plus 2h squared. Oh, this plus 4 here, sorry. It's plus 4. You can track it here from here. This is plus 4 here. So even here is plus 4. Okay. So let's continue. Plus 4 minus, now what is x? X is 2x squared plus 4. Okay, so 2x squared plus 4, close bracket, everything divided by h. Okay, so let's continue. So we just write equals here limit as h approaches to 0. We have 2x squared plus 4xh plus 2h squared plus 4. So we distribute a negative here. So this multiplied by this, it will be minus 2x squared minus 4, because here is also positive, so the negative h. Okay, so let's continue. Limit as h approaches to 0. So we group like terms. So this minus 2x squared, this and this. Okay, then we have plus 4xh plus 2h squared plus 4 minus 4. Okay, so 4 also we regroup it with the 4. Okay, h. So let's continue. So we have limit as h approaches to 0. So this will cancel. They have alternating sign. This is positive, this is negative, so this will cancel out. 4 positive, negative, this will also result to 0. So we'll have 4xh plus 2 h squared. So we have over h. Okay, so let's continue. If on top here we can factor out h is common, so we can factorize. So we have limit as h approaches to 0. So you have h here. When we remove the h, you will remain with the 4x inside, plus here we'll have okay, so I'll take 2x to over h. So you've seen h can cancel out of the denominator and denominator, numerator and denominator, so you can cancel out the h. Okay, so you have a limit h approaches to 0, so you have 4x plus 2h. Okay, so this is our final equation we have remained with. So now, how do we get the answer? So this limit as h approaches to 0, what it means is, so if we substitute where there is h, we put 0, what will be our answer? So we'll say 4x plus 2, where there is h, we put 0. If we apply this limit, so we are applying the limit here, because we have reached the end and we still have h. So where there is h, you substitute 0. Then the limit here, you don't write the limit here because you have applied it. When h is 0, this is 0 here. So we have 4x plus 0. So this will be just 4x. So this is your answer. So f of x prime equal to 4x. So this is your answer. Okay, hope you guys are following. So if you have any queries, you can quickly write me messages. Like I always emphasize, you can always query. That's the beauty about this page. Okay, so now what I'll do next is I'm trying to create a separate video for sine, cosine, and tangent. So in this video, I'm not going to touch the cosine, the sine, and the tangent because they are quite lengthy. We need to do first. We need to do some trigonometry before we start. So I'm not going to tackle D and E in this video. So we go to F. So f of x equals to e to the power 2x. So we have f of x equals to power x. Then we have, now we go to f x plus h. So where there is x in this equation, we are putting x plus h. Okay, so we say e to where there is x plus h. Okay, so this is the same as e. If you follow through, it will be 2x plus 2h. Okay, so yeah, this is this part. So just multiplying by 2 by x, 2 by h, it will be like this. And there are those who know from the row of the indices that if I'm multiplying numbers, I mentioned it earlier. So for example, n, you are multiplying it by 2 to the power m. This is the same as 2. The bases are the same, so you are adding the power n plus m. Okay, hope there are those who remember. So meaning this, you've seen there is this part added to this part. This is the same as e to the power 2x multiplied by e to the power 2h. Okay, so hope there are people who remember. I can also write another identity. Let's say 2 to the power n over 2 to the power m. You know the powers are the same. There is 2, 2. So you just write 2. This will be n minus m. So you just subtract the powers here. If you're dividing numbers of the same base, you just subtract the powers. But if you're multiplying numbers of the same base, you add the powers. So this is what I've done. If this is the same as e multiplying e, so you're multiplying e to the power 2x multiplied by e to the power 2h. The base is the same, so you add the powers. This is the same as e to the power 2x plus 2h. Okay, so hope you guys have understood this part. Okay, so next, let me write it here. Let me just write our f of x plus h. This is e to the power 2x dot e to the power 2h. Okay, so I'm writing them like this. You see why I've written them like in this order, which is the factorized, or the in form of multiplying indices. Yeah. So now we apply our formula. X prime equals to limit as h approaches to 0, f of x plus h minus f of x divided by h. Okay, so this is the same as f of x prime equal to limit as h approaches to 0. What is our f of x plus h? So this is e to the power 2x dot e to the power 2h. So minus, what is our f of x? What is our f of x? E to the power 2x. So this is e to the power 2x over h. Okay. Okay. So now let's continue. So we have f of x equal to limit as h approaches to 0. So we can factor out here. So that was the whole point of us doing everything we were doing to write this. We were supposed to factor out this. So we can factor out e to the power 2x. So inside you have e to the power 2h minus 1 over h. Okay. Okay, so now what is remaining here? So what is remaining here? So we can just say so this is just the same as this part here. This part is the same as 2x. Well, let me first start with the limit so that you guys follow through. Okay, so we factored out e to the power 2x, so we remained with e of so we factored out limit, so we remained with, so this is same as e to the power 2x. It's same as multiplying this by e to the power 2h minus 1 over h. This is same as if you multiply this by this, it will give you the same. Okay, so we continue. Okay, so you need to also know some basics. So there are some basics which you guys should know, some, let me say, some identities. So if you're taking a limit of h as it is approaching 0, if you have a function e to the power, let's say a h minus 1 over h. This answer should, when you take this limit, the answer should be a. So you're just taking the coefficient here of h. So hope that is clear. So if you have limit as h approaches 0, e to the power, let's say 10h minus 1 over h, you know that your answer will be 10 because the coefficient of h here is 10. This is what this identity means. So you just have to know the identity, that limit as h approaches 0, e to the power ah minus 1 over h is going to be a. Okay, so multiplying this, we can even take this before the limit because it's just same as multiplying. Okay, so I will write this part if x. So it goes like this: limit as h approaches 0, e to the power 2x. Then we have e to the power 2h minus 1 over h. Okay, so this is the same as nothing is different here. If you say e to the power 2x, then limit h, because this limit, this is independent of h, so this limit does not affect this term whether we put it in front or before. Okay, then we have now e to the power 2h minus 1 over h. So applying this identity here, so I will write the identity again. So limit as h approaches 0, e to the power a h minus 1 over h is equals to a. So a is a coefficient of x here, whatever number you have, this is the one which is going to be a. So meaning f of x prime equal to e to the power 2x. So we know everything here. This part will just give us 2 if we apply this identity, to give us 2. Okay, so meaning f of x prime is equals to 2 e to the power 2x. Okay, so this is your answer. So kindly know this identity. I'm emphasizing again. E 2h minus 1 over h. This will just be the coefficient of h, which is 2. Okay, so if there is 10, you just write 10. Okay, that's it for this question. Let's go to another question. So G, so we come to G. So f of x equals to natural log of 2x. Then we write f of x plus h. So where there is x, we replace it with what? X plus h. So natural log 2x plus h. Great. Okay. So you guys are following through. So let's continue. So let's simplify further for this part. So we have natural log. So this is same as 2x plus 2h. So you know logarithmic functions. If for example I say natural log of a plus natural log of b, this is same as natural log. This is same as if you're adding, meaning you multiply. This is the same as ab. Okay, so natural log a minus natural log of b this is the same as natural log of A over B. So addition is same as you are multiplying the what, the numbers here. So it can be variables, it can be what, so you are multiplying. Okay, then subtraction, you're dividing through. Okay, so also know this part, you should know this. So it's important also, you know, when you're adding, the same as you're multiplying the numbers, the contents of the natural logs. Okay, so now let's apply our formula. F of x prime equals to limit as h approaches to 0, f of x h minus f of x, everything divided by h. Okay, so we have limit as h approaches to 0. What is f of x plus h? That is natural log of 2x plus 2h minus, what is f of x? 2x. So it's natural, so we just erase. Right. Okay, so natural 2x, so this is over h. So now we apply our identity, which is natural log of a minus natural log of b is same as natural log a over b. So our a here is this part and our b is this part. Okay, so if we apply this, you have f of x prime equal to limit as h approaches to 0, natural log. So what is a? A is 2x plus 2h over what is b? B is 2x. Okay, so this is the numerator divided by h. So I hope you guys have followed through how I've come up with this. I'm applying this formula here. I'm applying this identity here. So the identity is this one. So a, natural log of a, so a is this one. If it is minus here, we are dividing a and our b is this side. So it's this minus this, so meaning a is this, b is this. Okay, so if you see here, we can factor out 2 on top. So we have limit as h approaches to 0, natural log. So on top, numerator you have 2 x plus h over 2x. So you guys are following through. Here is over h. Okay, so we know the 2, this guy can go. Okay, 2 can cancel out, so remain with this is equal to limit as h approaches to 0, natural log. So we've cancelled out the 2 over h. Okay, so you've seen here we can separate these two numbers so that h is independent of x. Let's get them separate. Oh yeah, so we did part of it, we did partial fractions decomposition, you guys remember, from integration as h approaches to 0. So on top, the same as we have x is divided by x and h is divided by x. They have a common denominator x, so it's x over x plus h over x. We are separating these two terms. This is divided by x. Also, this is divided by x. There is nothing complicated here. Just splitting the terms. So you will see why we are splitting the terms. Okay, so limit is h approaches to 0. Natural log. So x over x is what? 1 plus, so you have h over x. Okay, so we have over h. Okay, so why were we separating? Why were we separating these two terms? This is fx. Why were we separating these two terms? So now, what we have to do is, if you can see here, h is divided by what? 1 over x. If you've seen here, this is h over x. So how can we make these two terms same? This one. How can we make it so that it becomes like this? Okay, that's the puzzle. So how do we do that? Well, we know if we have h, if we multiply it by 1 over x, this is same as over 1. It will be h over x. Okay, so if you guys believe that, if we multiply h by 1 over x, it will give us 1 over h over x. So what do? This term here. So you multiply, the multiplier is 1 over x. So without changing the equation, how do we keep the equation the same? So we multiply on both the numerator and the denominator by this value. Because we can't just multiply in the denominator 1 by x, meaning we have changed the equation. So we are multiplying the same multiplier, the numerator and the denominator. So if, for example, you have 2 over 3, let's say if you want to maintain the equation, you multiply by the same number. So if you multiply by 3 here, even at the denominator, you multiply by 3. This will still cancel out, will still remain with this. So that's what we are doing here. We are multiplying by the same factor, both the numerator and the denominator. Okay. So why are we doing that? We want to create an identity. We want to create an identity to get rid of this. We want to create an identity. Okay, so so I've seen why are we, what are we multiplying with? We want to get this fact, this value here at the denominator. How can we do that? We will multiply by 1 over x, both the numerator and the denominator. If you multiply the numerator and the denominator with the same number, you are not changing anything. So that's a motive. So you have the limit as h approaches to 0. So the numerator 1 over x multiplied by, so you have multiplied by limit, in the brackets nothing will change, so plus h over x. Okay, so over 1 over x multiplied by h. Okay, so we have limit h equal to 0 as h goes to 0. So this term here, we can take it out because it is independent of h. Okay, so we can write it before the limit, like we did for the previous example. Yeah, so like we did for the previous example, we take the 1 over x on the numerator. Why are we multiplying with 1 over x? I've explained. We want to create an identity in such a way that we get rid of what? The natural function. So we are trying to get rid of so meaning here we can take out this part. This is the numerator here. This will be limit. So this is our limit h. Why are we writing it here? It's independent of x. It doesn't affect the equation. Then on top we have natural log 1 plus divided by. So here now 1 multiplied by h to be h over x. So this is what we were looking for, because we wanted to employ this identity limit as h approaches to 0. If you have a natural log 1 plus a over a, the answer is what? 1. So no wonder we were trying to make this denominator same as this part here. So these are standard identities which you guys have to know. You just have to know it. Okay, so if here we had h over 2, we could have multiplied by 1 over 2, 1 over 2. If here it was, let's say, h over 6, we would have multiplied by 1 over 6, 1 over 6. So that the numerator is the same here. This and this, a has to match. So no wonder we were multiplying by this factor here, 1 over x. We were trying to make this denominator to be equivalent to that part without changing the equation. So having said this, we know that 1 over x, this, or this, our a is h over x. So h over x, even here we have h over x. So this will give us 1. The limit as h approaches to 0 of this will give us 1. So we'll say multiplied by 1. Then this is our f of x. So f of x prime equal to 1 over x. So this is your answer. Okay, so hope you guys have enjoyed the lesson. If you have questions, you kindly reach out. So we'll end here for today. Yeah, so continue liking my videos, follow my page, invite your friends and families, and let's learn together. Okay, so thank you. Enjoy the rest of your day.